Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, Chad Gill here. I'm the host of the This is Concrete podcast, where we talk with leaders in facilities management, architecture, contracting, and more. Global Polishing Systems is a sponsor of this podcast. GPS is an industrial and commercial concrete polishing, floor coating, and covering company. GPS is capable of handling intricate projects from warehouses and data centers to intricate designs for retail and commercial spaces. We firmly believe in prioritizing safety, quality, and client contentment while providing durable floor finishes. So check us out at globalpolishingsolutions.com today. Another sponsor is Workforce Recon. Workforce Recon is a project tracking software that connects the office to the field crews. The app Field Recon is built with a field-first mentality. Developed by contractors for contractors, it includes time and asset tracking, messaging, job documentation, and scheduling all in one place. So if you're tired of finding out what happened days later, check us out at workforcerecon.com and see your operation in real time. So joining me today is Don. Oh no, I should have asked you how to pronounce your last name, Don. I apologize.
No worries. It's Don Ajamian.
Ajamian. See how I would have guessed. I would have hacked it up. Let's be honest. It was who knows what was going to happen there. But Don is the CEO of Emergent 3D, a licensed general contractor in California for 38 years. He's built many homes and commercial structures, and he entered the 3D construction printing industry after the 2018 Carr fire in Northern California to help address the challenges in the construction industry today. His goal is to spark an interest in the listening audience of the possibilities that his technology holds for disaster recovery, disaster resilience, and workforce development and creative designing. Don, thank you for joining me. Very excited to hear what you're doing with 3D printing. I think this is like the flying cars of construction. Like, we were supposed to have had this years ago, and it seems like it's coming on though.
Yeah, Chad, thank you. Thanks for having me on, and I get excited to share about this new technology. As you said, I've been in the business for a long time. I got into it in my early 20s with my father, and so you could say construction's in the blood. And as contractors, we're slow to move. We're very conservative by nature, and so we're slow to move. And so having this come along, I'd say towards the latter part of my career, has been quite exciting and reinvigorating for me personally, being able to apply my years of experience into this new and innovative way to build.
Yeah. So, so you're regular construction, stick built, framing, standard, commercial, regular construction, and then you see what happens during the Carr fire. And you're like, okay, so, well, just quick sum up, what exactly was Carr fire? Like how extensive was that?
Yeah, so the Carr fire, like you said, it came through in 2018. It's when I first, maybe the phrase fire NATO was coined because of the Carr fire. So it was called the Carr fire because of where it happened to start within Shasta County here. It was near the Carr powerhouse. And so this fire took off and the winds picked up, and actually me and my family had to evacuate out of our home as well. And ultimately, when it was said and done, there were some 1,400 homes that were lost and 1,800 total structures. And there was a time when, as I said, I was evacuated, that I would have swore that our home was gone too. And so I remember, even as a contractor, I remember even my feeling of hopelessness, like, where am I going to go, and where am I going to, put my family up, and where are we going to be? And what I learned later is many friends of mine had the same thoughts, but they said, it's okay, I know Don, so we'll get a house or something. So, I didn't want to tell them that I was kind of shaking in my boots too, because it's so unsettling. We had a couple of hours to pack up a few things that we thought about saving, and we assumed everything else would be gone. And so for anybody that's experienced that, you know exactly what I'm talking about. And so after the fire came through, and a few days later, thankfully we learned our home was saved, was spared. The by the way, the fire had burned about half of our fence, and somehow they got the fire out because, as you know, a lot of times these fences are the fuses that end up bringing the fire to your eaves and ends up burning your house down. So somehow they got to us right in time. But it was when FEMA came in to Shasta County after that, they handed our leadership a notebook that was about 2 inches thick, and it said, here's kind of what to expect, and here's your long-term recovery, outline for what it would look like. And so was born the long-term recovery committees, of which I was asked to be a part. I've lived here in Shasta County. At that time, I had been in Shasta County for 28 years, and so most of my career was right here. And the leadership of the community knows me, and I know them, and so they asked if I would join that long-term recovery group, and I was heading up the case. I'm sorry, I'm going to talk about the case management side later. I was heading up the construction subcommittee because there was some 300 homes that were lost by folks that had no insurance and needed some sort of way of getting back into a home somehow. And so we were tasked with doing that. It is at that time that I met a gentleman by the name of Matthew Guile, and he was heading up the case management side of things. And it was Matt that told me about this idea of concrete 3D printing. He has 4 very young boys, and as he was thinking about what does the future hold for my kids, he stumbled upon that, and then lo and behold, the car fire happens, and he tells me about it, and we're thinking maybe this is a way that we rebuild in this day and age, right? As a longtime contractor, I can tell you firsthand, we have suffered from a lack of young people wanting to come into our industry. One of the stats that we often quote is for every 5 of me that's aging out of the industry, there's only 1 young person coming in. And so the simple math for me is that we need to automate the process by 80% just to keep up. And the truth is we're not keeping up. There's so many homes needed. There's quite a shortage of homes here in California, in my home state, and most parts of the country and the world can say the same thing. So this idea of automation was very interesting to me. The idea of not only does the automation leverage a shrinking workforce, but the technology side of it attracts potentially a new type of workforce. And anecdotally, I could tell you my very crew, I'm jumping ahead a bit, my very crew that is doing the 3D print work represents a demographic of young people that would not have ordinarily come into the trades. We've got a young woman on the trade, not that there aren't young women in the trades, but it's just not a demographic that's normally, represented in the construction industry.
Certainly a few are.
Yeah. And so we're attracting more of a tech generation because these aren't backbreaking, hard physical jobs. These are tech construction jobs. And so it has attracted a new workforce too. So it really does show promise to addressing the labor concerns that construction has.
Where do you pick up? So, when you think 3D printing, I'm used to, I've looked at everything from, true stick-built modular homes to SIPs, structural insulated panels and those kind of things. But when you're talking about 3D printing a home, you're printing it out of basically, I guess, a reinforced grout, or is it a true concrete, or how does that work? And where, I assume you're still gonna have wood trusses and that kind of thing, or no?
Yeah, so for us, we're here in California, and all I can share with you is what we got approved here in California. We are using a true concrete. We're locally sourcing sand, gravel, and cement, and we have our own batch plant that we batch our formula up, and we add other, ingredients. There's plasticizers and fibers that we put in, and it just makes it 3D printable. But it's locally sourced, generally speaking, locally sourced materials, and it is a concrete product. It's got some 3/8 aggregate in it. It's not just a mortar. And for us, we found that's the more economical way to do it. A lot of other companies are doing more of a mortar-based mix, but the 2 issues with that is, one, it's quite a bit more expensive. If I can quote a few numbers, I can tell you that some of these pre-packaged mortars for concrete 3D for mortar 3D printing are running around $600 to $700 a cubic yard. And you have very little variability. All you can do is add more or less water to it, but that's about it, you know. So when you're dealing with environmental conditions, there isn't a whole lot of variability. Ours, we can produce for about $250 a cubic yard on site with our additives. So we're saving there. But the other major savings on our side is our mix, and with our equipment, we could actually stack our material. We could do layers that are up to 1.5 inches tall. And we can't do that with some of the mortar mixes and some of the others that only go up 3/4 of an inch. And that may not seem like that big of a deal, but if you think about it, OSHA limits how fast we can run these machines, and that's a nationwide standard. We can only run these machines at a maximum speed of 10 inches per second, period. And so obviously as a builder and trying to be competitive, we want to run these machines as quickly as we can as we're mixing up material and running them. Well, if I can do 1.5 inch layer at a time instead of a 3/4 inch layer, I'm going to build that house in half the time.
Sure.
So we tend to lean towards the less expensive material, batching it on site and stacking it up taller, because it can and will be certainly more economical than smaller layers using the mortar. And then on top of all of that, it is a more readily acceptable product. Again, we're using conventional concrete that we're batching on site. Our mini batch plant spits out, batch reports every time we print, so we can show our inspectors and special inspectors exactly what we're batching every single time. So it shows the structural, consistency and integrity of what we're doing.
So, I mean, lots of questions for you. Sorry. So when you're doing this, rebar, I mean, what are you kind of sticking rebar in as you go? Is there rebar in it?
There is reinforcing, and a lot of it is going to be dependent on the structural design. So as we are layering up, we are installing horizontal reinforcing using a product that we stole out of the CMU construction industry. It's a product by Homan and Bernard. It's called DuraWall. It almost looks like a wire truss with a top and bottom cord and diagonal webs weaving back and forth, and we lay it in there horizontally, because every time we print a wall section, we're actually extruding 2 layers with a gap in the middle. We want to tie that front and back layer together, and that's what the DuraWall's for. So we install the DuraWall as designed by the structural engineer, but it's usually somewhere between every 12 inches, it's installed horizontally, but every 12 inches vertically to even out as far as 24 inches apart. And that's our horizontal reinforcement. And then here in California, what we've done is we would actually, part of our 3D printing, we're printing the walls, but you can call it, we're printing the skin of the walls. And we're actually printing up the skin or the formwork of structural columns. And so when we're done printing, we have these vertical chases that are wide open that we'd end up dropping a prefabricated rebar cage in. And then we fill that full of concrete and put a post cap on there. And that picks up, in our case, it picks up a wood beam and wood roof trusses that go on top of that.
So how are you keeping, electrical conduits or electrical in general, or are you just framing out the inside of the wall to do that, or in windows and door openings?
Yep. So on the electrical, again, every wall we print, whether it's an exterior wall or interior wall, it's actually, we're printing the skin of both sides, leaving a gap in the middle for things like plumbing, electrical, insulation when it comes to the exterior and so on. And so the electrical, we just have an electrician on site. When we get up to outlet height, he's just setting his boxes into place after we've passed outlet height. And the back of his box is within that void in the wall. And after we're done printing, he just fishes his wires up into the attic and makes up in the attic there. So he's installing as we go. you could say.
Huh.
And then you asked me, what was the other half of that question?
So yeah, the electrical and window and door opening.
Oh, windows and doors. So those are programmed in. We just program in the rough opening that we want in every case. And then windows and doors are set after we're done. And so in our case here in Reading, we took every door and window all the way up to the top and let the roof beam pick up our roof load. So we didn't have to 3D print a header. And that was just a design / cost analysis, right? I mean, the way most people are printing headers, if they do a drop header, is they will print up the sides of the opening, and once they're ready for the header, they install a piece of metal or something else to support a printed surface, and then you just print right over the top. And then you just have to come up with a way to trim it out and make it look pretty later. We thought rather than spend that time and money on making it look pretty later, we could just go all the way up to the top, and it's actually quite beautiful custom look. That's how we did those.
The houses you guys are doing. I guess this is. I mean, how many of these have you printed? I mean, these are beautiful.
So much of what you'll see on our site are some of our concept homes, and we have not done those. We've built 6 times. We've built what we call our wildfire restoration house. And it's a 1,200 square foot, 3-bedroom, 2-bath house, and we built it 6 times up here in Reading. And the beauty of building the same one over and over on these different sites is we've been able to mark our improvements. On our first homes, we actually ended up putting skim coat over the printed layers because we were learning, and it wasn't attractive enough in my book. So we put skim coats over it, but by the time we got to the last one, the owner loves it, and they're just going to paint it as is. We got it down better. But
I mean, the surface almost looks like rammed earth construction and that kind of thing.
It certainly can, and we've gotten even better than that. Since we printed the last one, we've been doing a bunch of R&D work on layer quality, layer height, things like that. We've actually gotten it better and better. So we are very much in the early growth stages, But then one of the things we found too, even printing the same house over and over, is we've played around with the tool path of the print head, and we've made that more efficient. We've played around some with the design, and we've gotten rid of different elements that weren't necessary, that were causing a lot of what I call dry movement, just movement of the print head without actually extruding anything, just to get from point A to point B. We've changed a lot of that. We've just become more efficient at it. So it's been fun to do that same one over and over again. And then we did a unique design that was actually designed by the students of Woodbury University down in Burbank in Los Angeles, California. We did a little 400 square foot home for them on their campus, and that was the one other unique design we did.
I see what you're talking about. Where you've got that open cavity, and I guess I don't know what kind of insulate. I guess you're just putting in like a liquid, like expanding foam insulation when you're ready.
Yeah. Here in Reading, we're just doing blown in loose fill.
Oh, okay.
Yep, we have a project coming up in Southern Oregon that they're using a spray-in foam, a closed cell spray-in foam. But it's up to the designer. You get a much higher R value with the spray-in foam. But down in Reading, our cavities were quite large, so we didn't need such high efficiency. So we didn't have to spend the money quite frankly, on the more expensive spray-in foam. So they're keeping their wall cavities quite a bit smaller up there in Oregon.
Wow, no, that's so. What are so how does it work? Are you using I guess I'm just trying to picture like a pump or something that's on a gantry or something in order to program and print these, and then do you just move if you want to build a bigger house, you just move the gantry around or move the columns, or I guess.
Yeah, so our current setup, we're using equipment manufactured by Kobod. Kobod comes out of Copenhagen, Denmark. They're, by most accounts, the world leader at this. They've by far sold more printers to anybody all over the world than anybody else, and so they're really a fantastic partner of ours. The current setup that we have, if we set up all the components of it, would give us a 3,000 square foot print area, and we could actually go 2 stories high. We could print up to 26 feet tall. We have yet to set up that entire, all those components, because the homes we've been printing are 1,200 square feet or less. And so it's all modular and you can set up less. And so that's what we do. We don't set up any more than we need. But we could do up to a 3,000 square foot footprint in a single setup with the equipment that we've got. And even that is, again, we're very new in this industry. So even that is being pushed. The new BOD, the COBOD machines, their BOD version 3 that they're talking about is even different than what we have. Rather than being on columns, it will be on rails. And so the expandability of that setup is even greater expandability and quicker setup and takedown. It's just, again, making us that much more efficient.
How high can you build? Like when you're printing, do you have to stop and let it harden and then print some more? Or I mean, how quick does it set up?
It sets up fast enough for us to keep going. If, one of the things we found is, once we hit our stride and you've got the mix dialed in and it's going well, we tend to work long days, and literally you can go as long as you want. It will support itself. You can go as long as you want, as long as the crew's holding out and you're willing to pay the overtime. You could just keep on going.
Rosie, bring in your second, third shift.
That's right. Yes, you certainly could.
I would imagine you draw quite a crowd when you start setting that thing up.
Yeah, it's fascinating, and I even find myself, I've watched it for hours, but I even find myself just lost in it. It's kind of mesmerizing just watching it extrude itself. It knows what to do and where to go. And one of the stories I tell is that, again, going back to our crew and the demographic that we're attracting, they don't really even have to know much about construction. They have to know about their jobs that they do, but literally my crew, I don't know if any of them know how to read plans. I've never actually had to ask them. It's not necessary. The computer is taking the file directly from the architect, right? The architect's designing in CAD or whatever file, Revit or whatever they're using. We take the hard file, we load it in our system, we run it through our slicing software. The computer knows what to do. The crew doesn't have to know. They need to know what to mix, how to mix it. They need to know, print speed and extrusion rates based upon the current climate and the conditions that we're under. And that's about it. Whether it's a 1-bedroom or 3-bedroom, I want to know that they loaded up the right file for the job site we're on, but that's about all they have to know.
I've had an out-of-date set of plans. I can't imagine printing the wrong house.
Yeah, that's right.
I assume you're printing. So are you printing on footings? Or are you printing on a slab, or how is that working?
Yeah, so part of it's going to depend. What we did in Burbank, they only had us doing the exterior, so we only 3D printed the exterior of the shell. So they poured their footings and we came and printed walls, and then they poured a slab in between us. And then there was a few interior walls that they framed up conventionally. The beauty of that is when you think about all these beautifully organic shapes that we can 3D print, by us actually 3D printing the walls before the slab gets poured, you're not gonna have a concrete guy that messes up your slab, right? We will print the forms for them, and it just makes their life easy. Just, hey, you pour it in between our walls and obviously it's going to be perfect. So that is kind of nice. On the ones that we did up here in Reading, however, we wanted to 3D print interior walls and all. So we poured footings and slab in a modified fashion, and then we 3D printed all of the walls in this case.
Wow. Well, man, I tell you, do you feel like you're speeding up the process, or there's still the learning curve there? Because you're taking, I guess you're replacing framing, the framing side, and in this case, your exterior cladding as well, and sometimes the interior cladding.
That's exactly right.
You're picking that up, and you're getting rid of most of your framing, your structural framing. Do you see it speeding up the overall construction of a house?
I do. Yeah. We're again, we may not be there yet, but yeah, absolutely. For those exact reasons you're talking about. When we're extruding our walls, we're not only creating the structure, but framing, but also exterior and interior finishes. And so all it really needs once we're done is paint, and unless somebody wants something different, but it's not necessary. So we can and do save time on the overall schedule. Part of the beauty of this, one of the things that, a skeptic might say is that you're actually stealing jobs, or, you're taking jobs away. But the reality is there are not enough carpenters out there.
Yeah.
And so, right. And so if there is a handful of carpenters, I can 3D print the walls and take that handful of carpenters and split them up and let half of them do the trusses on this house and half of them trusses on that house. And just don't worry about the walls. I can leverage that limited resource of carpenters to now just do the trusses. We still need that done. I could say the same for the drywall guys. We don't have enough to go around. So instead of having to do drywall on an entire house, hey, let's split you guys up and do the ceilings on 2 different houses or 3 different houses. So it's just leveraging a shrinking workforce to produce more homes. And that's the ultimate goal here.
Well, that is terrific, man. Like I said, I love these concept homes. I can't wait to see one of these get built. That is amazing. I'm sure you're excited about it too. You're like waiting for
that. Oh yeah, you and me both.
Yeah, we got a printer. We just need a check.
Right, that's right.
But I mean, it's a great looking finish. These are beautiful models, and even the projects you're doing. I mean, it's obvious. I mean, you guys are improving. Hand over fist there. It's just fantastic. So yeah, this is really cool stuff, and I really appreciate taking time and kind of telling us about it and learning more about it. I'm anxious to see what the piece is. So yeah, if you're in the California area and looking for a printed house, you've got a ready-made one ready for them.
Well, that's for sure. So Emergent was the first, and so far I think still the only to get a 3D printed house, on-site built 3D printed house through the California Building Code. We're taking on projects throughout the state, and as I said earlier, we're actually hopefully within the next 2 to 3 months going to start printing in Southern Oregon. And we've got a project forming in North Carolina, and we got a whole other batch of homes that are kicking off of all places, in Puerto Rico. And these are Puerto Rico, as you may know. I mean, it seems like they get hammered every year with hurricanes, and the beauty of, I guess, that market is that all the rebuilding that they are doing is with concrete. We don't have to convince them that this is a good idea. They already know that. And there is such a depleted labor force, we don't have to convince them that automating is a good idea. So we are actively securing projects in the Puerto Rico market as we speak.
Well, like you said too, I mean, you can print all night long. I mean,
that's right.
You really could rotate shifts and just keep printing. I mean, the speed, you're not worried about physical tiredness or, slower. I mean, I'm sure there's different safety situations, but so will you ship your printer to Puerto Rico or to North Carolina to do these?
We're actually, no, because we'll have multiple projects going at once. We're looking at, new equipment, probably at least a couple other printers once all of these get rolling. Yeah.
Fantastic. Yeah. Well, hey, I appreciate you taking the time and kind of looking at it. And it's Emergent, EMERGENT-3D.com.
Yes,
and
sir.
We'll put a link in the podcast for it, and keep following you. I mean, you hit North Carolina. I mean, I'm just a couple of hours from there. That'll be anxious. Let me know when you're hitting that area. That'd be great to watch.
Sounds great, Chad. I'll do it.
Thank you. I appreciate your time. We'll talk to you again soon.
All right. Thank you.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.